I do want to make you aware that these rule quizzes that you will get throughout this unit, antiderivatives and derivatives go hand in hand. So I will also make sure you remember your derivative rules, which if you know your antiderivative rules, shouldn't you automatically know your derivative rules also? Probably. Okay. So just, there's your warning. Okay. All right. So we're going to do some trig examples, and then we're going to look at what's called incomplete substitution. And that'll round out our section 5. Tomorrow we will review for Friday's quiz. So tomorrow we'll probably just do lots of examples before I let you work on your review. Like we'll probably get out the markers and either whiteboards or desks. Okay. Okay. Writing on the desk. Okay. It is. All right. So when we are looking at examples with trigonometry, and we sort of looked at this yesterday, but we have two options. Either we find a way to rewrite using identities so that we can use one of our basic rules, or if an opportunity presents itself to use U-substitution, we can look for those as well. Okay, so this is what I noticed. I noticed that cosine is in the denominator, right? And cosine and sine have a derivative relationship, right? You notice that? Okay. How should we take advantage of that? I heard two different things. Okay. What do we want cosine squared to be u? Okay. I'm going to come back to your suggestion in a moment. Okay. So we can let u equal the cosine of x, because then du would equal negative sine of x dx. Okay. Which is perfect because we have sine of x dx right there. Yep. I agree. So we have negative the integral of 1 over u squared du. Yeah. Cosine is inside of the squared, and so that's why we chose it. Okay. So you probably want to think of this. Don't make the same mistake as some of us did yesterday. Probably want to think of this as u to the negative second. We can only do our logarithmic rule when it's 1 over x or 1 over u. But as soon as there's a power, we have to use the power rule. So this becomes u to the negative first times negative 1 plus c, or 1 over u, right? Oh, okay. You know, we could have, okay. So let's go back to Austin's suggestion. Austin, you said that sine over cosine is. Okay, and if we have tangent over cosine, let's think about, he got tangent by taking sine over cosine. And if cosine's in the denominator, then we could write it as, oh, interesting. We have an antiderivative for tangent x secant x. Did we get the same answer? True. However, what's nice about this is that if you saw it the U-substitution way, it wasn't that bad. If you saw the trig identities way, yeah, we cut out a little bit of work, but it wasn't like terrible to use U-substitution. Sometimes we're going to have options, sometimes we're not going to have options, okay? So I just really want you to look for those relationships. We know that sine and cosine are derivatives of each other. We know that tangent has a derivative of secant squared. So if tangent and secant squared are together in an integral, that's exciting. Okay. You seem so excited. Everyone. All right. I want you to write this down, and then at your pod, just discuss what you think we should do. Don't write anything down, just discuss what you think we should do. You get smiled out. All right. Aaron, what did you and your neighbors discuss? We need to use U-substitution, and if we're going to use U-substitution, what should we let U equal? 1 plus sine x is the inside function for the square root. Also, its derivative is cosine of x dx. Well, that works out pretty nice because we have cosine of x dx right here. Do you have a question? You're thinking. Okay. Was this not what you were going to do? Oh, okay. So we can change our integral to be just the square root of u du. Is that it? Nice. Connor, help me out. Square root of u. How do we get the antiderivative? What would it be? Yeah.
Oh, plus C.
Thank you. You are going to do this one for me. Compare with your neighbor.
Oh, wait.
All right, Wyatt, what'd you do first? made du. Awesome. Over there. So 1/2 the integral of the sine of u du. Is that what you mean by 1/2 over there? Okay, do you agree with Wyatt? Okay, so Austin, our antiderivative would be? Okay, so -1/2 the cosine of x squared plus c. Thank you for remembering that the negative needs to be there for sine's antiderivative. Okay. All right. So sometimes we have a substitution problem where we have a composition, we need to use U-substitution, but we have an x left over. I know, right? So we're going to do what's called incomplete substitution with these, okay? Notice how we have a linear function inside of the square root, and there's a linear function on the outside of the square root. Okay, so some of your faces were like, what? Like, we're going to do this? This is going to happen? Yeah, it might be a little messy, but we're going to do it, and it's going to happen. Okay, it's going to be great. Okay, all right. Okay. Is that your philosophy? Out of curiosity, while we're kind of writing down what we need to, how many of you definitely know where you're going to be next year? Yeah, juniors, you know where you're gonna be. Okay. Nathan, you don't know you're gonna be next year? Okay. Isaac, are you going to Lincoln? Are you really? Oh, this is so exciting. I loved Kearney. Did you know that's where I went? Yeah. Yeah. Oh, it's so great. I have a master's from UNO and a master's from UNK in addition to my undergrad from UNK. So and I have another one that fell down. UNL asks their incoming freshmen to like write down a teacher who had the biggest impact on their education, and then they send you a note with a flag. So then I put it up. No, I had 2. Doesn't matter. Yeah, it's a beautiful campus.
It's really pretty, but the area that I would be in was not pretty.
Was not pretty. Which is the
It's like chemistry and stuff.
okay.
I wouldn't recommend it to chemistry.
So yeah, if you're looking for like not a big school like UNL, you want like a smaller environment, UNK was great. Oh, Buena Vista. Okay. All right, so we're gonna let be 2x minus 1 because that is what is inside of our square root. Now, we have the composition, we're letting the inside equal u, but what happens? Du is 2dx. That's really unfortunate because we don't have anything to substitute for that x. So this is what's happening here, people. Right now, we have the integral of, this is the square root of u, dx is 1/2 du, but we haven't replaced that x on the outside of our. Oh, what a quick, what? No, because then they divide each other out again. Okay? But Isaac, bring your eyes up to the one line before that. Do we have an expression that involves x?
Yeah.
Would we be able to rewrite this to be u plus 1 divided by 2 equals x? Kylie's really not excited about that. So we added 1 divided by 2, and now x is by itself. So now what we can do with this pesky x is we can write it as e plus 1 over 2, and that's going to be multiplied to the square root of u. Words. Yeah. Tell me how it's cheating. We're doing everything legal mathematically, right? Yeah, we can. Yeah. 1 step forward, 2 steps back. Okay, so now this is what's going to happen. Can we take the antiderivative right now? No. We cannot. However, we can probably distribute that u to the 1/2. What I'm going to do is I'm going to go ahead and write 1/4 on the outside because I can bring that 2 from the inside to the outside. And then we're going to distribute that u to the 1/2. So I'm going to write u to the 3/2 plus u to the 1/2.
Yeah, so. Yeah, this works.
Okay, are we okay with what we've done? Hard part is over. Is that a stretch or a question? Yeah.
So like.
What? I don't understand that. Yeah, once we take the antiderivative, then we'll go back to x. Is that your question?
Well, I didn't know.
Okay, so now let's take the antiderivative with respect to u. We have 1/4 times u to the 5/2 times 2/5 plus u to the 3/2 times 2/3 plus c. So I'm going to do two things at once. I'm going to distribute the 1/4 and replace the u with, was it 2x minus 1? So we have 1/10 2x minus 1 to the 5/2 and 1/6 2x minus 1 to the 3/2 plus c. It's not a pretty antiderivative, but in the beginning, we didn't even think this was possible. So even just like getting something is pretty exciting. Aaron's not convinced. That's fine. Should we do one more just so we can practice this trick again?
Yeah.
Okay, are you measuring in, what do you mean? Okay, yes.
Yeah.
Okay, are you gonna run or supposed to?
Maybe, hopefully I can run.
Okay.
Yeah. Right now I'm not fast enough, so.
There's water polo where you like sit in and like, I
See, I've been doing that.
Right? So it's like water polo except swimming, you're like getting in the tube, like. It's like-
Polo for lazy.
Yeah. That's what I call you.
Oh, man.
Oh.
But no, it's fun.
It's
It's
She just called you.
so fun.
I really think
She called him adventurous. That's
I feel like adventurous would be like you do it out in the ocean without.
water polo with the fishes. Whoever is not here today is really getting quite the lesson on many other things. Okay. We're gonna do it together. Some people take a little bit of time to write things down. Henry, what do you want to let U equal? Okay. U is x plus 4 because that is a function that is inside another function. So that's always a good candidate for U substitution. The problem is du equals dx. All right. So when we go to rewrite this, we have the square root of u in the denominator, dx is du. We have 2x plus 1, but we can't have x because we've changed everything to u's. If we rearrange this expression right here, Austin, what is x the same as? U minus 4. Now, 2 times the quantity u minus 4 plus 1 would be the same as 2u minus 7. And we are dividing by the square root of u, which is like multiplying by u to the negative 1/2. So I'm going to rewrite this integral to be 2u to the 1/2 minus 7u to the negative 1/2, because I distributed that u to the negative 1/2 to the binomial there. Because this is u to the first. Yep. All right. So our antiderivative is u to the 3/2 times 2/3 times 2 minus u to the 1/2 times 2 times 7 plus c. Nope. I love Miss McCrone's laugh. Then we change u's to x plus 4s. Voila. If you have fallen behind on homework, please find time today or tomorrow to catch back up. Our quiz is on Friday, and I would really love for your first quiz to be a good foundation for your grade. Okay, realistically, we're gonna have the homework quiz in the grade book. Eventually, you're gonna have a rule quiz in the grade book. We're gonna have Friday's quiz in the grade book, and then I don't know if our next quiz is next week. We have a 4-day week next week, so our next quiz wouldn't be until the week after the 4-day week. Okay, so I don't want to like put pressure on you, like, but I want you to just realistically keep in mind this is gonna be in the grade book kind of by itself for a while.